We're still in note 7.1. I believe this is the third video. It was to simplify each expression using properties of exponents. Simplify would mean we would want to make sure that we get rid of any parentheses. And if we have the same base in more than one location, we want to consolidate it. So first of all, I want to make sure it's clear that this 3 at the beginning is raised to the first. The power to a power property says that we're going to take each of these bases, and whatever exponent we currently have, we're going to multiply it by the exponent on the outside. So it's going to be 3 to the third times x. Take 3 times 3 to the ninth. And then we have y to the fifth. We're going to have 5 times 3, so we're going to have y to the 15th. 3 to the third is 3 times 3 times 3, which is 27. That's the best we could do for that. This next one, there's not much we can do with this one at this point. Let's get rid of these parentheses by using the power to a power property. So we're going to leave 3ab squared alone. This is going to be 2 to the first times 3, so that's going to be 2 to the third. Then we're going to have a, 2 times 3 is to the sixth. And then b, 3 times 3 is to the ninth. And then 2 to the third, well, that's 8. Whoops. And then what else we can do is, if you have the same base, you add the exponents. So 1 plus 6 is 7. Same base, 2 plus 9 is 11. And then we can multiply the 3 and the 8 together. So we get 24, a to the 7th, b to the 11th. Number 13, different ways you can look at this. One way is to simplify your fraction, and we got 12 over 15. We can divide both of those by 3 and get 4/5. And then as far as your exponents go and your bases of a, we could say we have an a cubed on the top. We could cancel out with 3 of the a's on the bottom, and we're left with an a squared on the bottom. Lots of ways to do this. That's one possible way. Number 4, you could simplify what's on the inside first and then use the exponent on the outside, or you can use the exponent on the outside first. Let's say that we simplify what's on the inside first. For example, we can divide a into a squared. It's going to go a times. We can divide b squared into b cubed. It's going to be b left over. It's going to give us 3ab over 5 squared. Squared means times itself. It's the power to a power. So we're going to have 3 squared, a squared, and b squared over 5 squared. 3 squared is 9. A squared and b squared can't be simplified. 25 squared is 125. Number 5, once again, lots of different ways you could do this. Let's say that you don't, well, let's do this. I'm going to use the quotient property. So I'm going to have an x once and a y once, because it's the same base, x's. Top exponent minus bottom exponent, 2 minus 5 is negative 3. Here we got y to the negative 3 over y squared, so we take negative 3 minus 2 is to the negative fifth. Then if you want to use the power to a power property, we're going to have y to the ninth, x to the ninth and y to the 15th. And that's as simple as we could make it. Now you could do this same problem in hundreds of different ways. As long as you get to the same answer here, then that's all that matters. Number 6. Let's see. Can we simplify the inside right now? Okay, is there a factor of 8 and 27 we can divide both of those by other than 1? There is not. X and the y can't be simplified because they are different bases. So let's use the power to a power property. Let's apply the 2/3 to each factor on the top and the bottom. That's going to be 8 to the 2/3 times x. When you multiply, when you have a power to a power, you multiply the exponents. 3 times 2/3 is 2. And on the bottom, 27 to the 2/3. And then we're going to have y 6 times 2/3. 6 times 2 is 12, divided by 3 is 4. So we're going to have y to the 4th. We're done with these x squared and y to the 4th. They're not going to change. We can do this in a couple ways, this 8 to the 2/3. We can take 8 squared and then cubed root it, or we can take the cubed root of 8 and then square it. Both of these are equivalent to this. I prefer this one here. The cubed root of 8 is 2, so now it's 2 squared. Same thing here. The cubed root, this bottom number, is the root of 27. What times itself again is 27? Well, that's 3. So that's going to give us 4x squared over 9y squared. Best we can do, that's finished. Number 7, nothing to simplify on the inside. 25 and 16 have no common factors. We have no bases with the same, we have no variables with the same base. So let's say that you don't want this negative exponent. So we could make this a positive exponent by reciprocating the base of that exponent. And then the power to a power property, every factor on the inside we're going to raise to the 3/2. Power to a power, 4 times 3/2. 4 times 3 is 12, divided by 2 is 6. In the denominator, we're going to have 25 to the 3/2. So 16 to the 1/2, so ignore the 3 for now. So the square root of 16 is 4. So it's going to be 4 cubed over 8 times 8 to the 6th. 25 to the 1/2, in other words, the square root of 25 is 5. We haven't used the numerator 3 yet. And then from here, 4 times 4 is, did I screw something up here? No. 4 times 4 is 16, times 4 more is 64. 5 times 5 is 25, times 5 more is 125. All right, this next one, nothing can be simplified on the inside. I like my exponent to be positive, so I'm going to reciprocate the inside. And that changes the sign of my exponent. Now, let me do this a little bit differently. Let's say I want to take this just in parts. I'm going to leave the 2 on the outside, and I'm going to multiply by the 1/3 from the outside. So I'm leaving the squared out here. So I'm going to have 125 to the 1/3. B cubed times 1/3 is b to the 1st. Going to have 8 to the 1/3, and then a to the 3rd, because 9 times the 3rd is 3. So I used the 1/3 and distributed it. I don't want to use the word distributed. Terrible wording. That implies distributed property, which is for addition and subtraction. This is not that. We use the power rule, the power of a product rule, and we applied this exponent to every factor on the inside. Now the cubed root of 125 is 5. Cubed root of 8 is 2. Now we can square this, power to a power, so it's going to be 5 squared, b squared, 2 squared, and a to the 6th, because we multiply the exponents. That's going to give us 5 squared is 25, 2 squared is 4, so we get 25b squared over 4a to the 6th. So 2 more in this video, slightly different directions. Rewrite each of the following expressions as a single exponential expression in the form of a to the m. So we need to have the same base is what this is saying. And if you look here, 25 and 5, they're not the same base. We could rewrite this so that it's 5 squared to the 3x plus 2. And then in each of these now, we have a power to the power rule. So you multiply the exponents for each of these bases. And then the product rule, you write the base once and you add the exponents. Done. This one here, first of all, this cubed root is the same thing as to the 1/3. So I'll do that. This 8, we need to have the same base as a 2. 8 is the same as 2 cubed. And that's already been raised to the 2x minus 1. Power to a power, multiply the exponents. So it's going to be 6x minus 3. And now the order in which we finish this, we can do in lots of ways. Let's say we want to make this into one base using the quotient property. Subtract the exponents. 6x minus 3x is 3x. A minus 3 minus a negative 6 is going to be a plus 3. Power to a power property, we multiply the exponents. We're going to get 2 to the x plus 1. That's going to conclude this video. We got 2 more to do after this. Yummy.